Hello, this is Steven Zhao, the Technical Director of Visual Slope. In this video, I will discuss with you about how to use a composite failure surface for slope stability analysis. As we all know, for a soil slope, most cases, we will use a circular failure surface for slope stability analysis, while for a rock slope, we commonly use translational or planar failure surface for slope stability analysis. However, in some cases like this, this is a slope contains soil on the top and rock below. We can use a circular failure for a slope stability analysis. And we see this is a failure surface. The factor safety is 1.34. Our experience commonly tells us a slope like this, soil may fail along the interface of the rock and the soil. Something like this, a circular failure followed by the interface, and then come out with a circular shape again. This we need use a so-called composite failure surface, which composed of circular and interface. How do we do that with visual slope? First, we can just draw limit lines along the interface. So this is the interface between soil and the rock, and we have drawn limit lines along it. And if we run a slope stability with a limit line, we will find the failure surface is still circular, and if we print out all the failure surfaces, we will find no failure surface will go beyond the limit line. However, this is not what we want. We want a failure surface composed of a circular and interface. So what we need to do is just choose composite shape and then run a failure slope stability again, and we will find now the failure surface is a circular followed by the interface and circle again, and the factor safety is 1.26, which is lower than the circular failure, which is 1.34. So this is why in some case we need use a composite failure surface. Further, for most programs they can provide a composite failure surface analysis. Visual slope go one step further because the interface of rock and soil usually is weaker than the soil strength. So we should reduce the strength of the interface. To do so, we just need choose the limit line, and in the reduction fact we can reduce the strength, say to 0.7 of the original strength, and here we can do the similar thing, say 0.5, and we can do this, say 0.7. After we reduce the strength of the interface, we run a slope stability with composite shape again, and we will find now the factor safety is 1.08, so even lower, and the shape is something like that. This is a composite fade-in surface, and the application for that is you have soil and rock. I will give two more examples for using composite fade-in surface. One is a landfill with a cap. Say this is a landfill, this is solid waste. After finish, usually we will put a geomembrane liner on the top and then covered with clay. However, we will check if the clay may slide over the geomembrane. So in this case, we draw a limit line, use it as a composite interface. So what we can do is we choose composite and then run analysis. And we finish, we find it's 1.0 something, so we may want increase the strength between soil and the geomembrane. This is one application. Another one is also a landfill project. This is a landfill which has no cap yet, and we want to check if the landfill, the solid waste itself, might slide over the liner. So we can put a limit line here and to see the slope stability condition. We also choose composite shape. And see, this is the potential fade-in surface, but so far the effect safety is pretty high. So those are the examples of using composite fade-in surface for slope stability analysis. This concludes this presentation. Thank you for watching.